I welcome you to organic chemistry class. We are going to take biomolecules, that is chemistry in biology. So in medicine we have so many organic chemistry we are using. Some of the examples and the categories we will take. Similarly, the molecules which are involved in the biological reactions, the prominent molecules also we will take. Under this biomolecules we have carbohydrates first. Examples like glucose. Glucose is a carbohydrate which has a formula C6H12O6. In fact, this also can be written as a 6CnH2ON. That is where N is the 6 if you take 6 carbons and H2O6. Okay, that means it looks like 6 water molecules are attached to the carbon. That's why they named as a carbohydrates. But later on it is proved it is not just the 6 water molecules, but glucose has a structure of an aldehyde. Glucose is primarily an aldehyde containing 6 carbons. On each carbon we have one OH. So more than one OH, the compounds will become unstable. So we have one OH on each carbon, rest are the hydrogens. This is the structural formula of the glucose. So we have an isomer for the glucose. At the second carbon, if a carbonyl group is there, first carbon CH2OH, the last carbon is also CH2OH. OH and OH is common. This is called fructose. So if you see carefully, the glucose is an aldehyde, fructose is a ketone. This is a aldehyde. They are defined as the carbohydrates are nothing but the carbonyl compounds containing polyhydroxy, and there is an optical activity. There is a 5 carbons here are showing the optical activity. 5 carbons are optically, no, 4 carbons are optically active. In this 2 carbons are optically active. Okay, 3 carbons are optically active. Here 4 carbons are optically active. So optically active polyhydroxy carbonyl compounds are known as carbohydrates. Among them, this glucose and fructose are the most important molecules. Now the carbohydrates can be classified. Classification of the carbohydrates. Carbohydrates are divided into the 2 types. The old classification is sugars and starches. This is one method of classification. Sugars are soluble in the water and the starches are not soluble in the water. Later, the carbohydrates are divided into in a different way. Carbohydrates are divided into the mainly 3 types. Monosaccharides. Saccharide refers to a carbohydrate unit. Monosaccharide, oligosaccharide and polysaccharide. Monosaccharides are glucose and fructose. Oligosaccharides are di, tri, tetra, up to 10 you can take it as under this maltose, cellulose, raffinose, and polysaccharides, starch, cellobiose. Cellobiose is the disaccharide, not cellulose, cellobiose. Cellulose is a polysaccharide. Cellulose is a polysaccharide. So this is based on the classification. When you hydrolyze this disaccharide like cellobiose or maltose, when you hydrolyze, you will get the 2 glucose units. So that's why they are called disaccharides. If it is giving a 3 monosaccharides, trisaccharides. So up to 2 to 10 we have defined as oligosaccharides. In some books, monosaccharide, disaccharides and oligosaccharides also we have. Poly means more than 10 monosaccharides if it are there, this is called polysaccharide. Okay. The monosaccharides are on hydrolysis, there is no further the breakage, such a single piece type of the compounds, carbohydrates are called monosaccharides. The monosaccharides also can be classified into the 3-4 varieties based on the number of carbons present in that compound. The smallest carbohydrate is 3 carbon, one is known as a triose, and 4 carbon one is called tetrose, pentose and hexose. This that means a triose means 3 carbons containing one, tetrose means 4 carbon containing, 5 carbon containing. In the hexose we will get this glucose and the fructose. In pentose we have ribose, which is a important one in the DNA RNA construction. In tetrose we have erythrose and threose and so on. Triose glyceraldehyde is the example. Even this the hexoses also we have further classification. If you take hexoses also further divided into the aldoses and ketoses. Aldoses, glucose is example. Ketoses, fructose is the example. So glucose is an aldose. Glucose is an aldose because it has an aldehyde function. This is based on the carbonyl function nature we have classified. Glucose is an aldose. Glucose is an hexose because it is made up of 6 carbon one. Glucose is a monosaccharide. On hydrolysis it won't break up. Glucose is a carbohydrate. Okay, it is a carbohydrate containing monosaccharide nature, containing hexose nature, containing it is a aldose. It is an aldehyde function containing one. So the glucose, fructose are important for the biological, that is in the biology of the carbohydrates. Carbohydrates are the ready energy for the in the human body or the in biological systems. Carbohydrates oxidize to the ethyl alcohol, afterwards it is oxidized to the carbon dioxide, it gives a energy for the body. So therefore carbohydrates makes an important role in the this one.